Okay, so now let's continue on how you're going to find your R out for your common drain. So this is the equivalent circuit of your common drain. So when you do a common drain, you are going to swap the circuits, right? And what you need to do, the R out that you mentioned in the gain just now is R out parallel to RS, right? So this is not the real R out. So now let's find the real R out. First step, what you need to do is you need to make the input shorted. So means remove your input source and make it shorted. And we are going to assume here your RSI is equal to 0. Okay. Then what you need to do, you need to add a test source. So we call here Vx. And here is your Ix. So how you're going to measure your R out? So looking from here is the value of your R out, the real output resistance. So your R out is Ohm's law, Vx over Ix. So we didn't use any V out here. Okay. So now let's see what will be the value of Ix. Okay, so Ix, we apply KCL. So current entering equal, let's say this is I1, this is I2, and since this is 0, right, so it becomes a short circuit, and here is I3, okay. So now let's see, current entering is Ix equal I1 plus I2, okay. Okay, look at here. When there is a short circuit over here, current will not go to R1 parallel to R2, so you're going to ignore this one. And there will be no current flow at the VGS. So that's why current entering here equal I1 plus I2 and nothing happened at this side. Okay, so your I1 is actually, voltage here is Vx, right? Because this is parallel. So Vx over Rs plus Vx over R0. So you separate this one. Okay, and then also I3. So here we assume this one. If I delete this one, so here is Rs, and we have another one here is R0. So here become I3, this become I2. Okay, so it become minus, not plus, minus Gm VGS Ix. Okay, now look at the relation now between VGS and Vx. So if I move this one down, so VGS here down, so the relation between Vx and VGS is negative. Okay, so what I need to do now is to try to remove this one to Vx. So it become Ix plus GmVx is equal to Vx over Rs plus Vx over R0. Okay, and I take out my Vx. Okay, so it become Vx 1 over Rs plus 1 over R0. So just now there is some correction here. So since Vx is equal to minus VGS, so this one should be Ix minus become plus GMV, so become minus GMVx. Okay, so here become plus 1 over GM. So if I rewrite again, sorry for the saying. Okay, Ix equal Vx 1 over Rs plus 1 over R0 plus 1 over Gm. So from here, you know the relation of the parallel circuit is actually 1 over R out. It's actually Ix over Vx. So you can get directly 1 over Rs plus 1 over R0 plus Gm. So sorry for this one again. So this one is actually GM. Okay. And then this is the equation of the parallel circuit. So you know R out is actually RS parallel to R out parallel to 1 over GM. So this will be the real output resistance for the common tree.